one of the projects in our lab is looking at ways of protecting islet cells when transplanted from the recipient immune system. And one of the ways that we do this is to encapsulate the cells in a polymer that basically protects them from being recognized by cells of the recipient system. Over the years, we found that one of the biggest problems with encapsulation is the inability of the cells to get oxygen that they need to survive and thrive inside the capsules. And also, the capsules are not tight enough, basically. They don't have pore sizes that are small enough to protect the cells from free radical species that the immune cells produce. So one of the ways we thought of counteracting that is to basically create enzymes inside of the capsule. So use the enzymes that are normally in our body that break down these free radicals, and when they do this, they generate oxygen. So we looked into the chemistry behind that and found out that these enzymes have metal cores that are made of a compound called manganese, and we're now using that manganese to produce nanoparticles that go inside of the capsules to generate oxygen from the nasty species that the immune cells produce.
So there's this chemistry demonstration, and it's called Genie in a bottle. You can watch it on YouTube. Which you put hydrogen peroxide in a bottle, some manganese oxide on top in a tea bag, and when you open the bottle, it drops into hydrogen peroxide, produces oxygen, and it looks like a genie coming out of the bottle. It's basically what we're doing. We're using manganese oxide, and there are oxidative species like hydrogen peroxide and superoxide that are produced by immune system to hurt the implants, and our manganese oxide transfers this hydrogen peroxide to oxygen, and which is helpful for the implant.
So we just recently published some of this work in the journal Acta Biomateriala, looking at the synthesis of these metals. We have synthesized over 20 to 30 of these different manganese compounds, and we found certain ones that we found to be optimal for achieving the goal of producing oxygen for the encapsulated cells. And now we're moving on to incorporating these into the polymer matrices and studying how they protect the cells from insult from the immune system.